welcome back, ladies and gentlemen, boys and girls, cats and kittens. We're talking about 2.3, Day 2, polynomial division. We're going to be using division to factor and find the zeros of polynomials. Okay, before I get going too much, you'll notice down here in the lower right corner, I've got the assignment already. That was just a space-saving issue for those folks printing the notes. Basically, I saved you a sheet of paper this way. You had one sheet of paper that just had the assignment on it. I thought I could do better and save you an extra sheet that way. Okay, but anyway, getting to the lesson. Alright, there's a couple theorems in the book, and really there's a whole lot of fanciness to them, and I tried to trim it down and not worry about the titles of all those fancy theorems, but here we go. Alright, those theorems basically say something to the effect of A is a zero of f of x, if and only if. Remember, if and only if basically is a statement that means you can go forwards or backwards. You can switch the hypothesis and the conclusion, geometry terms, and you still have a valid statement, is all that really means. Okay, so anyway, so a is a zero if and only if x minus a is a factor of the original polynomial. Okay, and again, a just being some number like 7 or negative 2 or even like something like 3 root 7. It doesn't really matter what a is, but if that number is a zero, that means that x minus a is a factor. So basically what that means, again, if it's a factor, that means when you divide, your remainder is 0 when you're dividing by whatever that factor is, in this case x minus a. Okay, we'll do some examples with this, and I do have a little summary at the end of this thing that'll hopefully clear that up, because right now it probably sounds a little bit fuzzy, but here we go. Okay, another consequence of this statement having a zero of whatever number that is, it lets you know that a comma 0 is an x-intercept of the graph. And basically what that means, if there's a factor, the remainder is 0, and if you remember how we could evaluate things from the last lesson, polynomials being those things, okay, when you plug in that a, you got whatever in the remainder box was the answer, and if that answer is 0, well, then basically you have an ordered pair of number comma 0, so that makes it an x-intercept. Alright, again, we're going to play with this a little more as the lesson goes on, but there you go. Alright, now let's start putting that theorem to the test a little bit. Okay, going on to factoring using division and giving all solutions. Kind of splitting the directions for the book up a little bit here, but here we go. Alright, if I'm given some polynomial like this, and notice now it's an equation, not necessarily a function. So basically what we're going to be doing here is solving by factoring. But if I have x equals negative 2 as a solution, okay, instantly what that tells me, because of that theorem on the last slide, that this right here tells me that x plus 2 is a factor of my original polynomial. Alright, and okay, hopefully you can think of that in terms of like just some basic factoring. If I had x plus 2 and I asked you to solve for x, well, hopefully you get x equals negative 2 pretty quickly if this was part of a string of parentheses and it was set equal to 0. Alright, so basically that's what we're going to try to get ourselves to as we look at this guy right here. Alright, so I know x plus 2 is a factor, and so now I can choose to either use long division, which I wouldn't, or use synthetic division, which is much nicer. So I'm going to divide my factor out of this guy here. So again, if I have x plus 2, that means a negative 2 goes in the box. Again, basically if you're taking a shortcut there, whatever that is goes in the box, but I think it's a good idea to always think back to the factor. That prevents some sign mistakes that people tend to make on occasion. But anyway, put my polynomial there and get my little remainder box ready. Alright, again, drop down to 2. Negative 2 times 2 is negative 4. Multiplying there gives me a negative 13. Multiplying there gives me a positive 26. Adding gives me a 15. And then by no coincidence whatsoever, we get a negative 30 and a 0. Again, basically that's what that theorem previously said. If I have a solution, that means I have a 0. That means I have a factor. Those things kind of all go hand in hand. Okay, so basically what this means is this leftover thing here is 2x squared minus 13x plus 15. Okay, now admittedly what's really going on there is that is a part of the factor where the other factor is that thing we kind of pulled out at the beginning, the x plus 2. So my original x to the third polynomial, you can see if I kind of start flowing this thing out, I still have my 2x to the third. I'm not going to waste your time by doing all of it, but feel free to do that if you think I'm giving you all kinds of goofy lies right here. Alright, well, now I've got this guy, and if I can keep factoring, well, I'm in business. Of course, if I can't factor this, I can always use the quadratic formula or something like that. But let's see if we can get this guy factored, because that's usually quicker. Alright, so anyway, got this going on here. Well, if I put a 5 out here, and a 3 right here for my 15, and then sprinkle in a couple of minus signs, okay, I do get the factored version of this. Again, feel free to verify that. But anyway, if I'm going to give all my solutions now, because this is now my factored form, my solutions to that equation are going to be the -2 that we kind of had at the beginning, and then we've got a 3/2, or of course 1.5, or whatever you want to use, and then 5. So there's the final answer to that using synthetic division as an aid, and that's kind of how that theorem can be used to solve a fairly complicated equation. Alright, now from that last example you were probably thinking, well yeah, that was an easy number, what happens is messy? Well, here's what happens when it's messy. Alright, we've got x equals 4 plus root 2 is our solution. So what that gives us is x minus, okay, and pardon me, I'm going to be subtracting the entire thing, so it's really x minus 4 minus root 2 as my factor. Okay, so now basically again translating it back into the box, I'd have to take the opposite of what you're subtracting from x, which kind of like what I referred to in the last one is basically just brings you back to the beginning, at least what you were given as a solution in this case. So basically that's what's in the box, and it is kind of a messy sort of thing. Okay, now as I start writing my coefficients here, I get a 1, and I'm not going to write this -11 real close to the 1 because I'm going to be using this binomial sort of thing. It's not technically a binomial, but you get the meaning, it's 2 terms. Alright, so I'm going to leave a little bit of space here so I make sure I have room to write. So the -11 goes there, again leaving a pretty sizable gap for the 38, and then again a very large gap here for the 42. Alright, now put my underline down in my remainder box. Okay, well, if this is a solution, what should happen here is a 0. Okay, so that's kind of a little bit of foreshadowing there, just to throw an English term out there for you. Okay, but the process does work the same, you just have a messier multiplication to go through. Okay, 1. Okay, well, that times 1, of course, is it. So 4 plus root 2. Okay, as you do this, you get a -7, just putting your like terms together, make sure you don't put the radicals together with the non-radicals, and you get that. Okay, then doing a little bit of FOIL right here, I'll save you the pain of watching me do the FOIL on that, and if you need some assistance with that, let me know. But as you FOIL those guys right there, you should get a -26 minus 3 root 2. Okay, adding again just your like terms gives us a +12 minus 3 root 2. Okay, and then again, if you're really slick, you look at that and you think, hey, that's 3 parentheses 4 minus root 2, and 4 minus root 2 is a conjugate to this guy, so as I multiply them together, I should get a rational number when I'm done. But let's not go there right now. But anyway, we multiply those two together, and believe it or not, it does give us a nice +42. And again, it gives us the 0 that we were expecting, so we're all kinds of happy. Alright, and then here's the fun part. If I've got 4 plus root 2 as a solution, well, solutions like this come from doing quadratic formulas or completing the square or square rooting both sides, something to that effect, and whatever happens during that process, every single one of those has a plus or minus between whole numbery kind of things like that and radicals like that. So basically what we can count on is that we have 4 minus root 2 as another solution. Alright, so what we can do here is, honestly what I do when I'm doing this myself, I just write this right next to that answer, but for clarity's sake, or at least I hope clarity's sake, I'm going to recopy these guys just to show a separate thing. Okay, so I'm now dividing this into an x squared plus messy stuff sort of thing. Again though, counting on this as being a solution, I'd expect a 0 there. Okay, dropping the 1, we got 4 minus root 2. Okay, putting that together gives me a -3, and those guys cancel out. That's convenient. And now multiplying this, well, 4 times -3 is a -12, and then root 2 times a -3 gives me a +3 root 2, and sure enough, those guys cancel each other out completely, giving us a 0, and again, making us very thrilled. Alright, so now at that point, we actually do have a factored polynomial. Alright, again, kind of like I said at the beginning, one of our factors is x minus 4 minus root 2. Okay, kind of by reading into things, this is one of our other solutions, so again now it's x minus, and again subtracting this entirety gives me 4 and then a plus, making sure I distribute the negative, root 2. And then again, notice what I'm down to here is just simply an x minus 3. Alright, so there's the factored version of that, and admittedly with the factored version it's probably harder to see the solutions than kind of going off what we've already said, but whatever the case, this is a solution of 4 technically plus root 2 out of the first one, and then 4 minus root 2 out of the second. Of course, we could have written this as 4 plus or minus root 2, and then 3. And again, there's 3 solutions, keeping in mind that, of course, we started with an x to the third, so having 3 solutions down here should not be a shock at all. Okay, now if you thought that last thing was just monumental, just chaos in action and looked too confusing to handle, here's another option. Lawton method. I've at least brought it up a little bit in class, but here it is. Okay, if I've got x equals this as a solution, I'm going to kind of use what I used in the last one to a degree, but in a different way. That means that I've got x is 4 minus root 2 as a solution, so if I put those together, I've really got 4 plus or minus root 2 are solutions. Okay, now basically what I'm going to do is these 2 solutions come out of an x squared sort of expression, and so I'm going to kind of create my own x squared to get that. And by doing that, I'm going to subtract the 4 from both sides, and this gives me plus or minus root 2. Okay, now here's the really tricky thing. I'm going to square both sides, and I'll actually write this to help emphasize what's going on here. Okay, this, of course, is x squared minus 8x plus 16. And then this, okay, the nice thing about squaring, positives or negatives, they come out positive either way. So actually, I don't even care about those signs there. I do care, though, that the square root of 2 squared gives me a positive 2. And then all I really have to do now is bring the 2 to the other side, get x squared minus 8x plus 14. And there's a polynomial that would have these 2 solutions if it was set equal to 0, which is technically what this thing is right now. Okay, now basically there's 2 of my solutions, and I can get my third one by now dividing this out of the original. However, I can't use synthetic division anymore. Okay, so I do have to resort to long division. So I've got my x squared minus 8x plus 14, and that's going to be divided into this big old guy here, x to the third minus 11x squared, etc. Okay, now the good news is this is x squared, this is x to the third, so I'm only going to have to find x to the first as kind of an answer up here. So I do have some long division, although it's not going to be too horrendous here. Again, matching the x squared to the x third is only going to take an x, and now distributing that x through the original out here gives me an x to the third minus 8x squared plus 14x. Okay, now again, a really good idea, I think, is to change your signs. So minus plus minus now. And now I'll go ahead and do my addition. Canceling my x to the thirds. Now I have a negative 3x to the second. Okay, subtracting right here gives me a positive 24x. Yeah, that's a 4, trust me. And then we bring down a minus 42. Okay, now again, matching first to first. I've got an x squared, I got a negative 3x squared, so I need a negative 3. Distributing gives me a negative 3x squared, positive 24x, and then, by no coincidence whatsoever, a negative 42. And now again, changing my signs, positive, positive, although not really too much of a shock, I'm sure. Then those guys cancel out, you get a 0, and again the 0 remainder means it goes evenly and all those other implications. So now x minus 3 is my only other factor for that. So I've got the x minus 3, and then I've got, again, these other guys that came out of this. So really, again, if these are my solutions, my factors are x minus each of them individually, so I end up with the plus root 2, and then x minus 4 minus root 2. Okay, kind of the good news here is even if you goof that up and forget to distribute the negative, as long as you forget it twice, you actually still have something that's valid. And so there's my factored version of that guy, and then of course you still get the same exact solutions. I'm just going to end up with them here in a different order for plus or minus root 2. So basically your options are either a little bit of playing around and then using long division, or going with that very messy synthetic division. I leave it up to you, because I think one isn't necessarily better than the other, it's all opinion. Alright, moving on to a chunk of problems. Basically I'm going to model one of those. We're going to verify factors algebraically and graphically. Basically what they're going to give you is a function, which is a polynomial, and they're going to give you one or more factors and ask you to do 5 different things basically. And here we go. Okay, first of all, they're going to ask you to verify those factors algebraically. Well, if I'm verifying that algebraically, one thing I can do is divide them out of the original and make sure that I get a 0 remainder. So that's exactly what I'm going to do here. I'm going to factor out the negative 1, because again this x plus 1 puts a negative 1 in the box. And I've got 1, 3, negative 6, negative 24, and negative 16. Alright, so from there, we drop the 1 and just run through our standard synthetic division sort of thing. Those of you good at mental math will be able to tear through this in a very, very, very short amount of time. Alright, so there we go. So I got the 0, and again, the world is looking good. I'm happy. I've verified that that's a factor. Okay, now to verify the second one, I do have a couple options. I could go with the original function again, but basically what I've done so far is I've broken that x plus 1 off, and then I've got that x to the third left over right there. I'm not going to write the whole thing out, but basically that's what I've got. And so if I can divide this second factor into the original, well, it wasn't that factor, so it's got to be a factor of what's left over as well. So basically what I can do is divide now the 2 root 2 out of what I've got here. And so here we go. I'm going to take the 2 root 2 out, and again, now that I'm going to have some messiness, I'm going to take these guys and spread them out a little bit. 1, 2, negative 8, negative 16. Hopefully I can do this within that space. Drop the 1, and then I've got a 2 root 2. Now be careful here, those are not like terms, so it's got to be 2 plus 2 root 2. Okay, as I now distribute this to this expression here, the 2 root 2 hits the 2 and makes a 4 root 2, and I'm purposely going to write that on the right, because it's not a like term with this guy. As I take the 2 root 2 times the 2 root 2, notice you get 4 times root 4. The root 4 becomes a 2, so really that guy becomes an 8. And I'll put a plus sign in there to separate them. And those guys cancel, give me a 4 root 2. And hopefully not too much of a shock here. As I multiply the 2 root 2 times the 4 root 2, I get 8 root 4, which ultimately turns itself into a 16. And again, I get my 0 remainder. So again, my smiley face applies down there as well. Alright, so now I've verified those factors algebraically. I got a 0 remainder both times. I'm feeling good about life in general. Alright, now finding the other factors. Okay, well again, if I've got 2 root 2 as, you know, a 0 or a factor or whatever context we want to look at that in, it means I have the opposite as true as well. Because again, that came from a quadratic formula, completing the square kind of situation, so I do have a plus or minus. So now I'm going to have my minus 2 root 2 inside my box. And then again, now I got 1, 2 plus 2 root 2, and 4 root 2 is my kind of remaining polynomial. It's called a depressed polynomial technically, because I guess you've taken away some of its power, so it's a little bit sad. Alright, anyway, you bring a 1 down, multiply this, I get a negative 2 root 2. Okay, those guys cancel, leaving us with a 2. Distributing here, and actually it's not distributing, just multiplying. Now I get a negative 4 root 2, and again, I get a 0. Yay! I'm so happy about life. Alright, so we've got that. So basically now our other factors are going to be these guys, or at least the factors that come from these. Okay, now minus 2 root 2 means that I have a factor of x plus 2 root 2. And then this 1, 2 sort of thing, again, this is x to the first, and this is x to the 0. So my other factor is going to be an x plus 2. Alright, so there's the other factors. Okay, I didn't circle part A because basically it's like a proof, and the verification is that the whole body of work there. But that's the other 2 factors, so I do have a kind of more concrete answer that I can circle. Alright, now I'm still continuing with the last problem, so just because you don't see the polynomial on the screen, don't think anything weird's happened. I'm still working with that last problem. Alright, so basically now we're asking to be completely factoring the original. So instead of the f of x equals that x to the 4th thingy, we actually do have 4 factors. Okay, the first one was the x plus 1 that they gave us, and then they also gave us x minus 2 root 2. And then by part B, we figured out the other 2 factors, which were x plus 2 root 2, and then we figured out an x plus 2. Okay, so there's the completely factored version of that guy. You could write it in a little different order if you wanted to, but really, because it's all multiplication, the order doesn't matter. So there you go. Okay, now listing all the zeros, again, once I have a factored polynomial, the zeros, especially if all the factors are x to the first power, becomes pretty simple. So my zeros are negative 1, okay, and here's where I'm going to actually take the last factor and list the 0 a little more nicely, negative 2. Okay, and I only do that because out of these 2 now I can have a plus or minus 2 root 2 and just write things, you know, in a little more abbreviated fashion than I could otherwise. Alright, So there's all the zeros. Really, again, didn't really take too much work, but there it is. Okay, now they're going to ask us to confirm answers with a graph as well. Alright, well, okay, so again, here's where those theorems kind of all play off with each other. As soon as I have these 4 zeros, it means I do have these 4 factors. It means that I have x-intercepts, all those kind of things all rolled into one. Okay, so just for effect, let's go to red here. Alright, I have -1 as a 0, so that means I should have -1 as an x-intercept, and sure enough, there he is. I also should have -2, and sure enough, there he is. Okay, now those are the easy two, of course. Okay, now, alright, hopefully within your math career, at some point, you've noticed that root 2 is about 1.4. Okay, and well, since I have 2 root 2's, that's about 2.8. So 2 root 2 is about 2.8, and since I have plus or minus, I should have a positive and negative 2.8 as a 0, or as an x-intercept. And again, pardon this graphing program I used, gave me tick marks at every 0.5, but here we go. So that's 2, that's 2.5, and then before I got 3.0, I got something that looks pretty close to that, so I'd say that 2.8 looks pretty good. And likewise, go in the negative direction if that's -2, -2.5, and -2.8. So confirm answers with the graph. Well, yep, I think that has everything checking out pretty well. Of course, you can use the zero feature and get a more accurate definition. Well, not definition, but you know what I mean. Alright, now I'm putting our thinking caps on. Sometimes you're going to be asked, through the course of some mathematical problem, to divide some big long polynomial, again, and whether it's an equals 0 or f of x equals is kind of irrelevant. Sometimes you're going to have to division by something like x squared minus 9. Now initially, hopefully the first thing that occurs to you is, oops, I can't use synthetic division. So basically I'm going to give you 2 options here. Hopefully wheels are turning in your head right now. But option 1 is probably the more just blatant, go for it sort of thing, and that's going to be the good old long division. Alrighty, so just divide one by the other, boom, whatever comes out comes out. Okay, but option 2 is a little sneakier. Alright, well, because the x squared minus 9 is factorable, basically what we could do is divide by one of those factors first. So it would be your choice to do the x plus 3 or the x minus 3, doesn't really matter, but divide by one of them first, then divide the result by the other. So in this case, that'd be x minus 3 the second time around. Okay, so sometimes, even though you're not given a synthetic division scenario, if you are dividing by something factorable, maybe you could turn it into something that you can use synthetic division on anyway. You just have to be a little bit sneaky about it and recognize something that's factorable or not. If you'd like to test this, feel free. Use long division, then do those, and you should get an answer that's down there, the 2x squared plus 6x minus 8. Alright, now on the first slide, I said I'd kind of tie things together in the last slide, so hopefully after doing a few of these and following along, here we go. When you see the synthetic division, so I've got a 4 in the box, and I've got all those numbers, blah, blah, blah. I'm not going to read them to you, but, alright, that means any one of these things down here, and I will, of course, fill in the blanks as we go, but hopefully you can kind of know what they are before I actually write them. But, okay, well, first of all, if I have these numbers here, again, those are those coefficients, so seeing this, I see this, I have a 4 in the box, so that means I'm divided by x minus 4, and what that equals is, of course, that bottom line, x squared plus 7x minus 2, and there's no remainder, so I'm not going to put anything there. Okay, but what it also means is a factor of that original polynomial is x minus 4. I'll put it in parentheses just to stress the whole factor idea, but it'd be x minus 4, then you could throw parentheses and have your x squared plus 7x minus 2 from there. Okay, another thing that it means is the 0 of that polynomial is a positive 4. Okay, what it also means is a solution to the equation, if I said, again, equal to 0 instead of f of x, well, a solution is x equals 4. Alright, an x-intercept of the graph, again, if a 0 is 4, that implies the point 4, 0, so there we go. And for f of x equals this, f of 4, well, I kind of just already said it, but that equals 0. So, depending the context of the problem you're doing and the question being asked, this is the exact same work to answer any one of those questions, basically. So I guess the moral of the story here is make sure you realize that one of those implies the other, and, well, basically they all imply each other. And then, basically the directions are going to say one thing, so make sure you're interpreting the synthetic division you're doing correctly, so that you get the right kind of answer. Alrighty, there it is, and hopefully that made a little bit of sense. Otherwise, of course, ask me in class. See you guys tomorrow.